Are you able to see my screen?
Yes.
All right, I'm seeing 10:30 here. We'll give it a few more seconds before we start our next session. For those of you joining us today, you are joining the Thursday track for the Lower Fox River and Green Bay session. So welcome if we have anyone new joining us. Here are some of the wonderful things we get to look forward to today. At this 10:30 time slot, we will be highlighting 3 separate talks. Each talk will be about 10 to 12 minutes with the opportunity for a question or 2 after each talk, and then we'll move on to the next invited speaker with this session wrapping up at 11:15. We'll ask everyone, if you have a question for the speaker presenting, please utilize the question and answer or the Q&A box to the right of the presentation screen as you're viewing it to submit your questions for the presenter to answer or respond to. With that, I would love to introduce our first presenter this morning. I'm going to stop sharing my screen so that he has a chance. This morning, I would like to introduce you to Jim Snitgen with Oneida Nation, and he is going to be discussing and sharing with us several different restoration projects and new projects that he's had the privilege of being involved in the Lower Fox River region, and he'll be sharing with you the success stories of these projects. All right,
Good
Jim,
morning,
it's all
everyone.
yours.
It's a pleasure to be here. I'm going to show you 3 projects that we've done fairly recently with the different reasons behind them and projected outcomes, that kind of thing. So I hope you enjoy it.
Looks good, Jim.
All righty. Okay, so 3 Oneida stream and wetland restoration projects, different systems, different goals. So what I'm going to talk about is 2 stream and 1 wetland restoration project. The first one is a re-meander and riparian corridor restoration in a warm water system. The second is a wetland restoration and habitat enhancement in a cool/cold water system headwater. Then the third is a fish passage restoration and habitat enhancement in cool water tributary. So for all of those, I'll talk about the need, why we thought we should do them, some of the planning, and then pre and post monitoring, and some of the maintenance things that we're still doing and planning on these projects. So the first project is in the south branch of the Suamico River, a tributary to the Suamico that starts just west of the reservation and comes through and then flows back out in the northwest corner of the Oneida Nation Reservation. It's a warm water system. Our partners are working from downstream up to try to enhance northern pike spawning and habitat, and we're working from upstream on down. The goals of this were to not only for pike spawning, but also hydrology. So the stream, well, I'll show you in a minute how straight it was. So we wanted to re-meander to lower peak flows, extend base flows, attenuate flooding, but also enhance northern pike spawning, which part of that is the hydrology, but also the actual habitat enhancements. So here's an aerial shot. So north is to the left, up in the northern part of that reach there. And you can see from this photo, it's a good graphic on just how channelized this was. So the idea was to get this water out of there and get it downstream as quick as possible. So of course, we're going to try to undo that with our project. So this is on the ground, what it looked like, the actual stream channel during the summer, early summer. So obviously there's not a lot of habitat there, but there was water in there at least part of the year. Before we got into our wetter years, this thing typically dried up in July, early August, and for the last several years, it's been, except for last August, it's been a perennial stream. So here, after doing the design work, we hired a firm to go in and do the excavation. So here's a shot during construction of the channel. It's not a big stream. We had to take some land out of production from a farmer that leased the ag field to the west there, a cornfield, to extend or expand the buffer. Here's another shot of construction, and this shows what we were trying to do with the channel as far as having it slope back towards the stream. So the young pike fry can make it back down to the channel and work their way back downstream at the appropriate time. So so that's another goal of this, you know, part of the hydrology part, you know, other than slowing the water down. So here's another shot. The drone comes in real handy to tell the story of these projects. So this is looking towards the southwest, towards Olson Road, along that same channel during the re-meandering. As you can see, it was in September, we had some rain, and we started to get some water in there already. This was back in 2015. And here we are in May of 2016. We actually have someone down there trying to put in pike young of year traps down there. And those of you that have tried to, it's a real iffy roll of the dice to try to do that, as far as particularly in the last few years with our flooding issues. So that's May. We did lengthen the channel to 4,208 feet and establish 8.2 acres of native riparian vegetation. So this, because it's a warm system and because of our goals, we didn't do the corridor restoration where we try to shade it as much as possible, both to enhance habitat and kind of fight off climate change. And here it is ready for pike spawning in 2017 in the spring. So we really like the way that turned out. And like I said, there's been water in there, except for last August I went out there and it was actually dry like it used to be, like 2015 and previous. Okay, so I'm going to check my timer here. Looks like I'm doing pretty good. The second project is headwater wetland restoration, and this project was managed by Tony Kuchma, our wetland project manager. And it's in the headwaters of Trout Creek, a cold/cool water system that originates on the reservation and flows down into Duck Creek by County FF. So part of a larger project, and I'll show you kind of what the BMPs and the plans were for this in a minute, but this is what we're trying to fix here. You can see how wet it is out there on the former state farm and all that bare soil there. This was actually taken after we did a corridor restoration and re-meander, but because of the time of year, it doesn't really show up. But I'll show you kind of the general idea of what we're doing here. So the goals of this, restore wetland function to headwater wetland. So all those headwater wetlands that were ditched and drained up there, we're trying to reverse that, slow it down, clean the water up, but yet try not to raise temperatures anywhere. So create high water quality wetland habitat and improve water quality. So this was kind of the general plan for up there. So this involves hundreds and hundreds of acres. So in the northern part there is this project, the wetland, the 55-acre wetland construction. To the left of that, to the west, was reforestation. And last April, we went out and planted about 57 acres of trees. With all internal staff. We were unable to hire out the contractor, so we did it with a pull behind ourselves. There's also to the east of the wetland thing, that's going to be native prairie, and then kind of a mix to the south of there. And it's going to be incorporating rotational grazing that we've got going on to the south, where some of the cattle go up and browse some of the prairie species. So now you can see in the middle there the green corridor, and that's Trout Creek. So we want to provide shade there. We expanded the buffer, re-meandered it, and we want it to look like it does to the east of County U there with the forested corridor for a number of reasons. So this is looking west prior to the wetland project implementation. You may notice at the bottom of the picture, there's a nice wetland there. That was a cooperative project with the Wisconsin DOT, another headwater wetland to Trout Creek. And that turned out really nice. So we're developing quite a complex going across up here. This is construction looking northwest of the new wetland. There's going to be a nesting platform in there, and then kind of a bundle of woody debris that was put in there. Here's another shot looking to the southwest, kind of under construction. And because this was just finished this last fall, unfortunately, I don't have any after photos yet, at least drone ones, but we're expecting some good results, and there was some water in there already when I went by there recently. So we'll probably be reporting out on this later.
Wonderful. Thank you, Jim. Thanks for walking us through those awesome restoration efforts. And I think we all can agree that we're looking forward to seeing how that wetland comes together this year as it becomes fully vegetated and starting to function as a new wetland in that system. So one question that I do have for you, Jim, if you don't mind unmuting, is looking forward at your upcoming projects, which one are you most excited about? And you are still muted if you want to unmute. Jim, can you unmute to answer the question? I'll give him a couple more seconds and then maybe we'll move on to our next talk. I believe we may have lost Jim. So apologies, Jim, for not being able to get this to you. But thank you for that presentation, and thank you for sharing the wonderful work that you're doing through Oneida Nation for restoration in Northeast Wisconsin. Our next speaker that's going to join us this morning is Tammie Paoli with the Wisconsin DNR. She's a fisheries biologist. So with that, I'm going to let Tammie take it away here and share her screen and give us an update on Green Bay fisheries. All right, that looks good, Tammie.
All right, well, thank you everyone for joining me today. I have quite a bit of information to cover in a very short amount of time, so I'll go ahead and get started. I'd like to begin by highlighting some of the physical features of the bay that create the foundation for a diverse and productive fishery. So Green Bay is a protected arm of Lake Michigan that is bordered on one side by the Niagara Escarpment in Door County, that contains many embayments such as Little Sturgeon Bay, Sawyer Harbor, and Egg Harbor. There are a few small tributaries that enter the bay from the Door Peninsula, but the larger tributaries exist on the west shore, which the west shore also contains many wetlands along the relatively flat shoreline. Currents that move in a counterclockwise direction help form unique features along the west shore, such as Peshtigo Point, little tail point, and long tail point. Those features protect areas behind them from prevailing winds, which allows aquatic plants to grow and provides habitat for fish. The bay is just over 1 million acres in size, with about half of the area being less than 20 meters deep. Several large tributaries that empty into the bay add to the nutrient and sediment load and increase productivity for fish, particularly in the southern bay. You can see runoff from the Fox River and Duck Creek in this satellite photo. And I'm going to zoom in on one of the land features in the southern bay, Longtail Point. Longtail Point is one of several sand spits formed by currents and sediment transport through time. Behind Longtail Point is Dead Horse Bay, a protected embayment that is home to some of the largest catches of young of the year yellow perch in our summer surveys. In the winter, you'll find ice anglers in search of adult perch and northern pike here. With the increase in lake levels in the last decade, Longtail Point has gone from being a peninsula to a series of islands and risks being lost altogether if water levels remain high and a few catastrophic storms take it out. The previous slides highlighted how the geology and physical features of the bay influence the fish community. And before I begin talking about the fishery itself of the bay, I must mention the changes that the bay has undergone in the last several decades, since this is important to the overall story. From the 1800s until the mid-20th century, the Great Lakes became home to an occasional new species, common carp, sea lamprey, alewife, and rainbow smelt, to name a few. But in the lifetime of those of us listening today, the number of new invaders making an appearance is startling. The Green Bay ecosystem has undergone some major changes as a result of the interactions, directly or indirectly, with invasive species. The Lake Michigan Integrated Fisheries Management Plan provides the framework for fish management by Wisconsin DNR with 5 broad visions. Those are a diverse, balanced, and healthy ecosystem, a diverse multi-species sport fishery, a sustainable and viable commercial fishery, science-based management, and effective internal and external communication. Under each of these 5 visions are goals, objectives, and specific tactics. You can find this plan on the DNR website by searching Lake Michigan Plan. A 2017 and 18 study that was completed by the University of Wisconsin Whitewater Fiscal and Economic Research Center surveyed Green Bay anglers. That study estimated that the total impact of sport angling is $264 million and adds over 2,700 jobs into the local economy. This study focused only on Wisconsin anglers, so it is not unreasonable to think that the figure is actually much higher when considering anglers that fish in the Michigan waters of Green Bay. So for this talk, I'm going to focus on fish species that are targeted by anglers in the bay. These are the species that Wisconsin DNR manages by setting dates, daily bag limits, minimum size limits, commercial quotas, stocking, or habitat improvements. I separated them here by native and self-sustaining species, native but reliant on stocking, and non-native and reliant on stocking. These 9 species are managed by 4 fish biologists who work out of the Peshtigo, Green Bay, and Sturgeon Bay DNR offices. I'll provide a very broad overview on the status of each of these species. I'll begin with lake whitefish, a species of interest for both commercial fishers and sport anglers, and has been the focus of many public meetings. Whitefish are a relatively long-lived species for the bay, with a lifespan of 15 years or more. Whitefish abundance in the bay has increased compared to decades ago, partly as a result of increased reproduction in the large tributaries, such as the Fox, Oconto, Peshtigo, and Menominee rivers. There are discussions to increase the whitefish quota an additional 200,000 pounds as an emergency rule in 2021 within a portion of Green Bay waters. And there's a public meeting tonight to focus on that topic. Yellow perch are another species that support both commercial and sport fisheries in Wisconsin waters of Green Bay. Commercial fishing has been a way of life in many of the ports in Green Bay for over a century. Similar to whitefish, the perch commercial fishery is managed by a quota system. DNR staff collect data from anglers, commercial fishers, and surveys to provide inputs into a catch-at-age model that helps us to determine safe harvest limits. The majority of yellow perch harvested are 2 or 3 years old, so it's a fairly young fishery. We have documented an occasional perch over 10 years old, but even a 6-year-old perch is quite rare in the bay. In the 1980s and 90s, perch were in great abundance in the bay. Since the mid-90s, the yellow perch population declined significantly, yet it remains stable enough to maintain a commercial and sport fishery. Folks that lived through the heydays of the 80s often ask me, when are the perch coming back? That's a tough question to know the answer to, and much of this decline coincides with the changes in the bay, the influx of new invasive species, and changes with native species occurring in the bay starting in the 1990s. Unlike many of the other species, such as yellow perch, that have experienced declines in the last 2 decades, walleye have thrived on their own. The annual angler catch has doubled or tripled since the 80s and 90s. Much of the catch of walleye is during the spring runs, where reduced bag limits stabilize our harvest. Catch and harvest records were shattered in 2018 with over 250,000 walleye caught and 125 walleye harvested. While all of the species that I mentioned today contribute to the $264 million estimate of economic impact, walleye are certainly one of the most sought after species in the bay by sport anglers. There has been an increase in high-profile walleye tournaments, with some up to $500,000 prize value in the bay. The spring spawning run on the large tributaries provides some of the earliest opportunities in the state to fish for walleye, since the season for walleye on inland lakes is closed until the May opener. For a few weeks in March and April, and starting right around now, shore anglers and boat anglers will come from all across the Midwest to fish for Green Bay walleye, and anglers will line up along the riverbanks. Next, I'll talk about northern pike, which are an important top predator fish in the bay, and their population has been fairly steady despite wetland loss through time. Pike have a unique life history, and adults swim up tributaries and ditches to seek out shallow wetlands or flooded fields to spawn. They lay their eggs, which stick to the vegetation and hatch in a few weeks in only 6 to 12 inches of water on average. The baby pike drift back downstream to the bay, where the water flow can have a high mortality during dry springs. Projects to improve or create wetlands for pike spawning, such as what Jim just talked about before me, as well as improving culverts in streams and ditches, have all helped keep the pike population stable. We typically see strong year classes for pike about every 3 to 5 years. And we also see some trophy potential for northern pike in the bay, with it taking about 8 years for a female pike to reach 40 inches in the bay, which is considerably faster than a typical inland lake. A recent fish survey in the Sturgeon Bay, Little Sturgeon Bay area revealed that nearly 25% of the smallmouth sampled were 18 inches or greater. Historically low water levels on Lake Michigan, compounded by an increase in riparian dredging activity, threaten to directly impact the amount and quality of habitat available for smallmouth bass. Now, on the flip side, high water levels in Lake Michigan are resulting in miles of new riprap and hardened shorelines in prime smallmouth spawning areas of Door County. The cumulative effects of shoreline hardening on spawning and nursery habitat for fish, and not just smallmouth, are difficult to measure. The Great Lakes spotted muskie is a genetic strain of muskie that's unique to the Great Lakes, but were decimated during the early and mid 1900s by habitat destruction, pollution, and overexploitation. Efforts to reestablish this native predator have been ongoing since 1989. Wisconsin DNR stocks 5,000 to 10,000 muskies in the bay annually. The good news is that natural reproduction has been documented in a few areas, such as Little Sturgeon Bay and the lower Menominee River, but a self-sustaining population with no stocking is a ways off. Research projects have focused on determining habitat preference and movement of muskies to better inform agencies on appropriate habitat improvement techniques and stocking strategies. For now, the future of the fishery is dependent on stocking. And the sport fishery has become very popular, with anglers catching an estimated 4,500 muskies in the bay in 2019. Green Bay has become a destination fishery, with a lot of anglers focusing on the bay in 2020 because they were unable to go up north to Canada. Now we'll switch gears to non-native stocked sport fish species. Harvest for Chinook or king salmon in Green Bay has been on the decline and is now only a minor component of the bay fishery. Chinook stocked in northern Lake Huron move to Green Bay and contribute more to the harvest than fish stocked directly into the bay, based on quoted wire tagging studies by the U.S. Fish and Wildlife Service. We suspect that there's a high mortality within the first few months that Chinook are stocked in the bay, and as a result, stocking levels have been reduced in the bay over time. Rainbow trout are a highly sought after sport fish in Lake Michigan, and they provide stream and lake fishing opportunities. Wisconsin DNR stocks 3 strains of rainbow trout: Chambers Creek, Ganaraska, and Skamania. Harvest of rainbow trout from the bay is a minor component compared to walleye, perch, or whitefish harvest. A mass marking study by the U.S. Fish and Wildlife Service will shed some light on whether rainbow trout that we stock in the bay are suffering from high mortality after stocking, or if they're roaming around and are caught in other parts of the lake. The last species that I'll talk about is brown trout. Green Bay is a fishing destination for brown trout, particularly in the spring when trout are in search for food in shallow, warmer waters. Brown trout provide stream fishing and nearshore boat angling opportunities in the bay. This graph shows the number of brown trout stocked each year in the gray bars and the estimated harvest as the black line. You'll notice a trend here with the last 3 species of stocked salmonids showing similar drops in harvest over the last decade or more. In attempts to increase survival of brown trout that are stocked in April during their growing walleye runs, Wisconsin DNR now hauls brown trout offshore on our 60-foot research vessel to try to boost the chances for yearling trout to survive their first several weeks and months out into the bay. In summary, despite many of the challenges with invasive species, water level changes, habitat loss, water quality concerns, areas of hypoxia or dead zones, and non-point source pollution, the future of the Green Bay fishery is good, and it continues to provide a world-class fishery for many game fish species. Wisconsin DNR continues to monitor these fisheries and adjust sport fishing regulations, commercial fishing quotas and rules, and stocking strategies with input from our stakeholders. And with that, I'll leave you with my contact information, and I'm not sure if we have any more time for questions, but anyone can feel free to contact me after this presentation.
Great, thanks, Tammie. We do still have a couple minutes for questions, and we do have a couple, so I'll throw them your way. The first question that we have is, are there catch limits for species that require stocking?
There are. So we do have minimum bag limits for some of the species that actually all of the species that we stock. It depends on the species, but yes, we do have minimum daily bag limits for the species that we stock.
And is that information available on the DNR website?
Yes, it would be. It's available on the DNR website and also in the fishing regulations booklet.
Perfect.
And the new one should be coming out shortly.
Great. Good plug. We have another question here. Aren't king salmon naturally reproducing in certain tributaries?
Yes, good comment. We have learned that king salmon are naturally reproducing in some areas, primarily in tributaries in Michigan. We have not been able to document much, or if any, natural reproduction of salmon in our tributaries in Wisconsin. We have a lot of dams on our tributaries. Habitat is different. We have warmer water temperatures. So some of the more open systems in the state of Michigan is primarily where a lot of the king salmon are reproducing. So, and this is information that we really didn't know about 15 or 20 years ago, but some mass marking studies by U.S. Fish and Wildlife Service were able to reveal that about 50% of the Chinook salmon out in Lake Michigan are naturally reproduced.
Awesome. I know we have a couple more questions in the queue, but I want to thank Tammie and want to encourage folks to reach out to Tammie if you want to have continued conversations. I know a lot of folks are probably interested in, especially from the angler perspective, on a lot of the stuff that you presented. So thank you for being with us today, Tammie. If you want to stop screen share and we'll transition over to Molly's talk. I want to thank everybody again for participating today and remind folks to utilize that Q&A to the right of your video screen for questions for Molly, our last presenter here. So Molly Myers is with UWGB. I'm going to kick it over to her to share with us about a project that she's been a part of, linking soil health to water quality kind of across the Great Lakes Basin. So with that, I will let Molly share her screen. You're looking good.
Hi, thanks, Erin. All right. So,
Oh, Molly, you're a little quiet.
oh, is this better?
It's still pretty quiet. Can't hear you at all now.
Hello?
Can still hear you, but you're faint.
Okay, I'm trying to.
Do you want to try it without the headset, or do you need that for? Can't hear you now. Do you need to unplug?
Can you hear me now?
Yes, you sound wonderful.
Okay. All right, we practiced and everything and still. Okay, so now sharing my slides. Okay, so hi again, my name is Molly Myers. I'm with the University of Wisconsin-Green Bay. Thank you for joining me this morning. The goal of this presentation is to give you a brief introduction to a collaborative soil health study that's taking place at several sites across the Great Lakes Basin. I'll be sharing some preliminary results and discuss what's coming next with this study, and also discussing the role that conservation practices can play with improving soil health and water quality. So this picture on the left shows the locations of the 14 USGS edge of field sites where they're monitoring runoff on agricultural fields as these farms begin to transition to conservation practices. There's 5 in Wisconsin, all in the lower Fox Basin, 2 in Michigan, 2 in Indiana, 1 in Ohio, and 4 in New York. The edge of field monitoring started at these sites between 2012 and 2015, and the soil health monitoring component was added in 2016. The goal of the soil health project is not only to monitor the soil at the sites, but also better understand the relationship between the soil health and the water quality leaving these fields. The little inset on the picture on the left is in one of our Wisconsin sites, you can see the drainage basin and where it runs down into the flume. And then there's some of our sample points are on there. And then the picture on the right is an example of an edge of field monitoring system. This one is in Wisconsin, and it was taken in September of 2020. We were waiting for the corn silage to come off so we could do our fall sampling prior to any soil disturbance like manure applications or cover crop plantings. This monitoring is taking place on working farms. So we want to, which has challenges and benefits, and gives the producers valuable information on how their practices impact the loss of sediment and nutrient from the fields. Briefly, I just want to acknowledge our project team. So Kevin Furmanek and Matt Dornbush are co-PIs on the project from UW Green Bay, along with Ron Turco at Purdue University. Purdue is doing all the soil microbial analysis for the project. Matt Kamitsky with USGS is the project lead for all the edge of field monitoring in the Great Lakes. And Luke at USGS plays a critical role with the water data and the data analysis linking the soil and water data. We receive project support from staff at the water science centers in all the states, and NRCS provides project support and funding. So I mentioned this, that we're trying to link soil health to water quality, and it's a bit more complex than that. So I wanted to go over this conceptual diagram that shows kind of our current understanding of the different components that can influence edge of field runoff. On the upper right, we have the catchment, and I think of this as all of the fixed characteristics that we can't really change. So like the size of the drainage basin, is it a 5 acres? Is it 50 acres? What's the slope? What's the soil texture? And what's the long-term management history? Has the site been tilled for 20 years? Things like that. Field management. I think of that as the things happening right now that have direct impacts on what we're seeing in the soil and what we're seeing in the water. So nutrient applications, how much cover is on the field, and the timing of these things is really important. The hydroclimate, what is precipitation like, both at an annual scale and event-based? Are we seeing extreme rain events like we did in 2018 and 2019? And how do those extreme events directly impact edge of field runoff? And then the soil health, how do the chemical, physical, and biological properties in the soil relate to each other and impact water quality? So are we seeing excess nutrients? Is the soil compacted? And is the soil microbial community functioning and providing a nutrient cycling benefit? So it's not as simple as, does the soil impact the water, but more like, what role does the water play in this system relative to these other factors? So I love sharing data, so we're just going to jump right in here. So note that most of the sites here are still in a sort of a pre-BMP or transition phase, so they're not all like implemented conservation practices at this point. So we now have 4 years of soil health measurements at most sites. We're measuring about 40 different soil parameters, and I only have time to talk about phosphorus this morning, so we're going to do that. So this is showing Bray P in the top 15 centimeters of the soil by site and year. Box plots are nice because they show variation within the field. And you'll notice that some sites have 4 years of data, so they'll have, the 4 box plots next to each other, and some have less. We had some travel restrictions last year due to COVID, so we weren't able to get to all the sites, and monitoring has ended at some sites. So I also picked this figure because it most drastically shows how manure applications can influence soil phosphorus at the sites. So New York 3, 4, and all the Wisconsin sites receive annual manure applications, and the other sites do not. And some of these nutrient concentrations are in excess of what crop needs are, so that makes them more vulnerable to running off the field. We do see a similar trend of higher soil nutrients at our manure sites, so they tend to be higher in carbon and nitrogen as well. And then moving on to some of the water data. So starting at the figure on the left, this is a runoff index that USGS put together. So all the sites are on the x-axis, and the y-axis is the annual runoff divided by the annual precipitation. And you'll notice that the Wisconsin sites, and each of these little dots represents a water year. The Wisconsin sites tend to run off more than the other sites. And you'll notice, New York 3 and 4 are manure sites as well, but they don't run off very much. So then that's important to note when we go over to the figure on the right here. This shows total pounds per acre per year of loss. And again, Wisconsin stands out in the orange bars here. The shaded portion is the unfrozen time of the year, and then the unshaded part here represents losses from the frozen portion of the year. And we have nitrogen, phosphorus, and suspended sediment. So I just wanted to point out that the New York 3 and 4 do have that high soil phosphorus levels, but they don't have much runoff. So that's why we're not seeing them up there with Wisconsin on this. So then linking the soil and the water data together. So the x-axis here is water extractable phosphorus, and the and the y-axis is the total phosphorus losses from the field in the unfrozen time of the year. So we are seeing strong correlations. The fields that tend to lose more phosphorus also have more phosphorus in the soil. And next steps, so this is all I kind of had time for today, but we are working on some multivariate type models that are going to bring in other components so we can better understand how multi-factors like the soil biology, soil physical components like infiltration and bulk density are also driving these losses on the fields. And skipping ahead, I want to bring this back to kind of a practical level and what this really means for conservation practitioners and farmers. So here in Northeast Wisconsin, it's been so inspiring to watch the demonstration farms take off and really figure out how to make conservation work on their operations. They've improved their soil structure, and they're reporting things like, I can get into my fields easier for planting in the spring. They're reporting cost savings for reduced tillage, less passes on the field, things like that. Some farms are generating additional feed for their animals when using double cropping systems. So they're finding win-wins that really work for their operation, benefits their soil and our waters. Other studies have shown that conservation practices like cover crops and no-till can reduce erosion and sediment losses by over 80% on those fields. But in addition to stopping the soil losses, we also have to look at those soil and nutrient levels if we want to see decreases in the loss of dissolved nutrients from these fields. So we can't have edge of field monitoring on every farm, but soil sampling is very doable. especially if we can narrow in on what's most important to measure. We want to give farmers additional tools so that when they install these conservation practices on their farms, they can know more about the likely impact it's having on water quality. And this project's going to add to that understanding about what factors are most responsive to conservation practices in the soil and what soil parameters are giving a signal that cleaner water is leaving the fields. So more to come. And sorry I went over because technical difficulties.
No worries, Molly. I don't know if you have your contact information, if you want to just.
Oh, it's on the next slide. Yep. And all our wonderful students and all our fieldwork adventures. Yep.
So I just want to encourage folks, unfortunately, we are out of time for this session, but if you do have questions for Molly, please quickly snap a picture of her contact information and get a hold of Molly with any additional questions. And thank you, Molly, and thank you to Tammie and to Jim for being a part of our morning presentations. If you want to stop screen sharing real quick, I will throw our game plan up again and remind folks that we do still have a lot of wonderful opportunities left today. So please enjoy a short break and we'll see you at 11:30 for additional speakers with our keynote for the land keynote for today. So thank you again for everybody for joining us, and we'll see you again soon.